With this video, I'm going to explain some of my MATLAB problems in section 5.6 in Math 171. In 5.6, it talks a lot about exponential growth, and this is going to be the function that you're going to be using in a lot of these problems. And I kind of worked through maybe a few examples to kind of make sure we are all have a clear understanding of this section. So in this first problem here, it says a comic book was sold for $75 in the 1900s and was sold again in 1925 for $110. Assume that the growth value is going to be C and C initial. So usually it's written like C with a little O there. This O down here, or this P with a little O in the subscript, is called initial. That's the starting point of your number. So that's what this means. The P on the on the other side of the equal sign is going to be your ending result, your answer, ending result after a few years, after 10 years, after 7 years, whatever the years is for T. We plug it in. So we start at a certain amount for a number of years, and then the K represents the rate. So whatever the rate is, put it into, and I'll show you where the E is in the calculator. Put this all in, we get our answer as far as result after 10 years, 7 years, like I said before. So this is what the exponential growth is. We start at an initial population, a money amount, whatever the case it is, and then it grows to whatever the ending result is after a certain number of years. So in this problem here, it says find the value of K of the exponential growth rate. Assume that the initial C is $75. So this is where we get it from, $75. So for this first one here, we're going to kind of set it up and just place the information that they have here into our exponential function for A. So we're going to end in 1925. It ends at 110. So our result is going to be at 110. We started at $75. E, and then the K is what we're trying to find. So we're just going to leave this as K. And then T is actually going to be represented as 25 because if I start in 1900s, and I go to 1925, there's 25 years that pass. So T is going to be equal to 25. Now we go from here and just solve for K. And so because we're using E in the previous sections, you might have learned that the only way to cancel out E is to use the natural log, but we need to get it by itself first. So the first thing we're going to do is move the 75 over by dividing. So we have this result here, and I'm just going to leave everything in my calculator once I do it and just kind of show you step by step. And I won't be writing down all the decimals either because it's probably too long. But we get it. I feel it's going to be 1.466 to be the answer once we divide it. But I'm going to leave it because I need this whole answer when we do in our calculations. You don't want to round and say 1.47 or 1.67, something like that, and then use that answer. We want to use this whole answer here, and I'll show you how to use that also. So I'm just going to leave it as the fraction. So I'm going to have 110 over 75 is equal to, because these will cancel, E raised to K 25 times 25, and these being multiplied together. So to get rid of this ln, I'm going to take the E. I'm going to take the ln of both sides. That way, these two will cancel. So I'm now left with ln of this fraction, 110 over 75, is equal to K times 25. In order to get K by itself, we're going to divide both sides by 25 now. So divide this side by 25. We're going to divide this side by 25. And then we're going to put all this in the calculator. This is the answer. And then our ending result is going to give me what K is equal to. So let's do that all in the calculator. So I'm going to do the ln. And if you hit second and then the negative sign, it takes your previous answer and puts it all in here, so you don't have to write 1.46. This is all the decimals, and you can just put it in here like so. So we're going to close the parentheses, and we're going to divide it by the 25. So divided by 25. So this answer here, this result, 110 divided by 75 is right here. So the ln divided by 25. And we get 0.015. Depending on what MATLAB asks you to round it to is what you round it to. We'll just do 3 places past the decimal. So the answer is going to be 0.015. And if you need to change it into a percent, you move the decimal 2 places, so it's going to be like 1.5%. So that's going to be our K value. Now that we have the K value, we can actually make now for part B, it says find the exponential growth function. So all we're doing now is just pretty much placing all the numbers that we have here, but this time we're going to insert the K since we now found out what it is. So let's get a new screen. So for part B, we'll write our initial. So we have P is equal to, again, 75 is our initial. E, this time we actually know what the K is going to be. So we're going to write it as 0.015 and then T. So this is going to be part B, because again, it asks for a function. Anytime you need a function, you're not looking for an answer. You're looking for, when it says a function, you're looking for an equation. So that's the answer for part B. Now let's move to part C. In part C, it says estimate the value of the comic book in 1950. So we're trying to figure out what the price is for the comic book when the year 1950 hits. Since now we have the function, we first got to figure out how many years went by. So we're going to take the 1950, subtract from 1900, and that easily gives us 50 years that's passed. So we're going to take now the 50 years for T and go ahead and plug it into our growth rate, exponential growth rate function. So we're going to use the same initial, which is again the 75, because that's again what we're starting with. E raised to our 0.015, that was our K, times 50 now. So after 50 years, after plugging into the problem, we should know what the amount is going to be on this worth of this comic book. So 75, and then we're going to put second, and then ln gives us the E. 0.015 times 50. And if you have the older calculator, you need to put all this in parentheses when you raise it. The TI 83 or the 84 that doesn't have the screen, it looks like this, you need to put this whole thing up here in parentheses. So make sure you close the parentheses once you finish. So after 50 years, it's going to be worth $158.78, or whatever, again, my MATLAB asks you to round it to. So just make sure you pay attention to my MATLAB's directions, so when it says round it to the nearest whatever it needs to be. So that was part C. Now D, we're talking about double time. And in my slides in Moodle, you will actually see a little formula that represents the double time. And I'll quickly go ahead and restate it. If I need to find a double time, it's just saying that I want my result, whatever the initial is, to be doubled. So this P here, I'm just want to know when the result when it's going to be doubled. So we see here, if we go ahead and do a quick math, we know that if we take these are being multiplied together, these are being multiplied together, I can cancel out these. So basically, I'm just left with 2 is equal to E K T. And then I already know my K. So I'm going to put it in 2 is equal to E 0.015, and then we're going to go ahead and write the T because we're trying to figure out that double time. So again, to get rid of the E, we're going to take both sides and take the ln of both sides. So it's going to be the ln of 2 equal to the ln of E raised to 0.015 T. These will cancel. So once those cancel here, all I'm left with now is ln of 2 is equal to 0.015 T. Divide both sides by here to get T by itself. These cancel. So T is going to be equal to whatever this is, and we're going to go ahead and throw that in the calculator. So basically, double time is always going to be ln of 2 and whatever your K is going to be. This is what the meaning of double time. So basically, you're going to always use ln of 2 because we're doing that double, but the K is the only thing that's going to change in every problem that you do on MathWise Plus. So let's put in ln of 2, and we're going to divide it by 0.015, and we get the answer to be 46.2. So the double time, as far as in years, at this rate of 1.5%, is going to be like around 42 years when the comic book value is going to actually be double time or doubled. The last one, it asks for how much after which the book work is going to be worth $1,000. So we're going to try to figure out the year, how many years that's going to go by until this value of this comic book is going to be 1,000. So once again, just go ahead and put the result. The ending result is going to be 1,000. Is what we're looking for. We start at 75, E 0.015, and then T. So again, we're going to do our math, divide both sides by 75. That way this cancels here and here. I'm going to leave it as a fraction again because, again, you don't want to round as you go. The rounding comes at the end. So leave it as a fraction or leave it in your calculator like so. So I'm going to take the ln of both sides. So I have the ln of 1,000 over 75 is equal to, this ln cancels with this E, 0.015 and then T. We're going to divide both sides by 0.015 to get T by itself again. Pretty much a lot of this stuff repeats. Finding answers, just know what to put in the values for into this function here. So T is going to be equal to all this when we put it in our calculator. So ln in 1,000 divided by 75, and then this is going to be divided by 0.015. So it's going to take about 172 years, 0.7, 172 years before we see this comic book reach 1,000. All right, so let's move on to another example. Again, I'm going to put my formula off to the side. And for this particular one now, we're going to basically be doing a lot of the same things. In this time in 1900s, the population of a country was 2.85 billion. This is the initial. This is what we started with in 1900s. We don't actually have to add any zeros to billion. You can just use the 2.85 as your initial. The exponential growth is 0.175% per year. What is going to be the exponential growth function? So again, we're looking for just the function for A. So it's just going to be us plugging it into each part up here. 2.85 e raised to 0.0175 and then t. So this is going to be the answer for part A. There's nothing else you need to do the problem because I'm just looking for the function. Part B now, we want to know the estimate population in of the country that's going to be in 1910. So for this one here, again, you have to figure out how many years went by. From 1900 to 1910 is going to be 10 years that went by. So T is going to be equal to 10. And then we're just go ahead and just plug it into our formula or our function. So 2.85 e to 0.0175 times 10. And this is going to give us the population after 10 years. So 2.85 e. So remember, hit second and then ln for e. We're going to have 0.0175 times 10 equals, and it's going to be 3.3 or 3.4 billion people after 10 years. So about 3.4 billion people. So how many years will the population be at 4 billion? So we know it's going to be higher than 10 years because 10 years is 3.4 billion. But I want to know where the population is going to be 4 billion. So this is, again, the ending result we're looking at. So it goes on the end, or it represents our P. So 4 is equal to 2.85, 0.0175, and then T. So once again, we're going to divide both sides by 285. We're going to take the natural log on both sides so we can cancel out with the E. So this cancels out with the E here, and then this here cancels here. So we have natural log of 4.285. You can put that in parentheses if you would like. 0.0175 t. Then we're going to take this whole thing and divide it by 0.0175. Those cancel, divide this whole thing by it, and that gives us what our t should be equal to. So ln 4 divided by 2.8 divided by 0.175. Let's go. So hit enter, and we're going to get it to be 19 to be our answer, about 19.4. So 19.4 years. So it'll be about 19.4 years before the population hits 4 billion. Again, with the double time, like we discussed earlier, I think I deleted it. Let's go back and just write it out again. So that double time I talked about in the previous problem is ln of 2 over what k is going to be. So it's going to be ln of 2 all over, for this particular one, 0.0175. So let's go back to the calculator. ln of 2 divided by 0.0175. And it's going to be 39.6. So T, the double time is going to be 39.6. So hopefully this will help you get you through section 5.6 with these two examples and using my Math++ resources in my slides. Thank you.